So the exam is on Wednesday. Okay? Now, before we started reviewing last class, before I continue reviewing, I uploaded the model number 2. So let me go over that. Okay. It's right here. Let me open the file. This one is individual, so each one of you has to work on your own model. And this one is more of a model, because the one you completed for the financial ratio is mostly downloading data and doing calculations. But in this one, you have to set up the model so it works for a client, a customer. Okay. So in this one, I'm going to pay more attention to change a number and make sure that you get the right solution, the right answer. Okay. It's based on the amortization table. So you have to make a file. And it has to have the following. It's due next week on Thursday. So like the one we did in class, it has to have a box for the property value. And then use these numbers. So, and then I can change the numbers. But so the house will be $250, 20% down payment. Okay? And then you have to include a spin button so that I can click up and down. And it goes in 5% increments. So from 20 to 25 or 20 to 15, 10. Okay? So make sure that it works that way. Not 21, 22, but 25, 30, up and down. APR assume 6.8% and put a spin button so that the percentage can go up by 0.1. So for 6.8, 6.9, 7, 7.1. Okay? So if you don't remember how to do that, you have to go watch the video. You have to do a little trick there, dividing. Okay? And then it can be a 15, 20, or 30-year loan. So you put a box like that. So I can click 15, 20, and 30, and the payment has to be adjusted depending on the number of years. Just like we did in class, assume 12 payments per year, but I can change that to semi-annual. You have to include the extra monthly payment. For now, just input 0. Okay? And then if I change that to any number, it has to work. Now, this is going to be a complete model. So when you apply for a loan for a house, it's not just the down payment and the monthly payment that you have to make. There's a lot of expenses. So there's going to be a loan origination fee. Okay. And I found some of these numbers. Typically, it's about 0.07184 of the loan amount. Okay, so then it's a processing fee, underwriting fee, title service fee, survey fee, an appraisal fee, a government fee, and I'm giving you numbers here. Some of them are percentages, and some of them are just a fee, flat fee. Doesn't matter what the value of the house is. Property insurance will be $840 per year. And then there's a PMI. Have you taken real estate? A lot of you, not many of you. PMI is private mortgage insurance, and that's assumed 0.625%. And the PMI is paid when you give less than 20% down payment. So if you buy a house and you're using a loan, and you give less than 20%, you will be charged with PMI, which is private mortgage insurance. And so basically what you're doing is you're buying insurance for the bank in case you default on your payments. So the bank will be paid by the private mortgage insurance company. If you give at least 20%, they assume that you've been saving money, you're responsible, you're less likely to default, so you don't have to pay that percentage. So even though you're doing 20%, I still want you guys to assume that there's a PMI. Okay, and then now there's a homeowners association fee. In this case, it would be $600. Now, keep in mind that some of these fees are one-time payments, like the underwriting fee. That only happens when you're going to close on that loan. Doesn't happen every year. The PMI, it's every year. The HMO, it's every year. Property taxes are every year. So you have to account for that. Okay? And the reason is because in the end, in the output box, I'll show you here, but you'll tell your client This is how much is due when you close on that loan. It's all the one-time fees, down payment, and then you have to show, and then every month, you have to pay your minimum payment, the loan payment, plus HMO, plus property insurance, and that. The way loans work, if you haven't taken real estate, also when you give less than 20%, the bank will charge the minimum monthly payment, which is the loan, plus HMO fees, plus property taxes, plus insurance. So they find out, okay, how much is the HMO on an annual basis? So in this case, I'm assuming 600. So they divide that by 12. So your monthly payment will be the loan payment plus, the monthly fee based on that $600 figure. Same thing for the property taxes. The reason why the bank does that is they're going to create an escrow, which means they're going to take your money and put it in that account. And then at the end of the year, the bank will pay your taxes, your HMO, and your insurance. Even though you live in that house, it's not really your house. It's the bank's house. So the bank wants to protect itself, and so just in case you're not disciplined to save money, we're going to collect the money on a monthly basis, put in that escrow account, and then we'll pay all the fees and all the taxes. When you give at least 20%, some banks will say, we trust you, so you can pay your taxes at the end of the year. So they won't make an escrow account for you. So it will be your responsibility to save money for all of those property taxes, insurance, and all of that. But in this case, let's assume that there will be an escrow account. So you have to calculate for me the monthly payment plus the HMO monthly fee, property taxes, and all of that. And then with banks, the way it works is at the end of the year, because they do an estimation, and if there's more money in the escrow account, then they need to pay taxes, property insurance, and all of that. Then they will save the money for the following year. If taxes go down, they might tell you you have to give less to the escrow. Taxes go up, they'll let you know you have to put more in the escrow. The monthly payment never changes for the loan, but the monthly payment, the total payment, can fluctuate over the life because of taxes, insurance, and things like that. Okay? But in this case, let's assume that they're going to stay constant for the 20, 30 years. Okay? Now, you have to calculate the taxes, the property taxes, and these are used to pay for the school, for the city, for the Hidalgo County, STC, McAllen. You have to do this for 3 different cities. So the house can be in McAllen, Edinburg, or Mission. So somewhere in your Excel, you have to make a little table like this, and then if you click on this website, it'll tell you what the rates are for each city. Things like the Hidalgo County is going to be the same for all 3 cities. So all 3 cities are in the same county. But the City of McAllen tax, you make a new table for City of Mission, City of Edinburgh. So then you have to use if-then commands so that if I'm doing the calculation and I click on Edinburgh, Mission, or McAllen, it'll go if equals McAllen, then use this property tax equals Mission, use this one, McAllen, use this one, so the payment can change. Okay? And this is what you have to give me in the output box. So what is the minimum scheduled payment? You already have that because we built one in class. You just have to complement it. Scheduled number of payments, when you don't give an additional payment every month, the actual number of payments, how much is the down payment, total due at closing. That will be all of the one-time fees plus your down payment. Total interest paid over the life of the loan. You have that already. If I put an additional payment, what will be the savings? You're going to finish sooner. So, it has to calculate that for you. And estimated annual property taxes, the insurance payment. The amortization table has to include all of those columns. You already have most of those, like the number of payments, date, beginning balance, a scheduled payment. This is the new one. I think all of the others, you already have them in your table. The escrow, which will be the HMO, property taxes, and insurance. I believe only those 3. So there's a new column. Now, that escrow does not you pay that, but it doesn't affect the principal. So do not mix that with the beginning balance and the ending balance. Okay? But it has to be right there so that people can see. And then, to finish, you'll make a graph like this one. This is a composite graph or compound. They call them, let me show you, insert. Well, this is Word, this is not Excel. But you can combine bars with lines. And I didn't show you how to do those, but they're not difficult to figure it out. If you go Insert, Recommended Charts, well, you select some numbers. And they're going to be combo right here. So you can combine a line with bars. So you go there and you can show this. The purple here will be the taxes, insurance, and fees, which is basically the escrow. The green is the principal, the cumulative, and then the interest is right here for each payment, and then this is the balance on the loan. So you can see that in the beginning you pay more interest than principal, and then the interest payment, the component of the total payment, is getting smaller and smaller because you're paying off the loan, and the principal is getting bigger and bigger. So you apply more to principal. And then this one is your escrow. Now, in your graph, the escrow will be the same throughout the life of the loan. The reason why this one is high and then it drops, because once you reach 20% equity on your house, they'll remove the PMI and things like that. But in your case, it's okay if you just keep it constant throughout the life of the loan. So you don't have to do an if-then command. If equity is more than 20%, it just complicates things. So it'll be nice, just enough if you make it constant like that. So go through this. As far as the report, because all of this is Excel, all of those fees in the report include an explanation of what they are. So you're giving this to a client, and they want to know what is PMI. So you put PMI, and they put the definition so they know what are they paying for. Same thing, what is the appraisal fee for, survey fee. Typically when you buy a house, they send somebody out there to make sure the house is the size it's supposed to be, or the lot. So you have to pay for that. So you explain that to me. Well, not to me. You're making this for a client. Same thing with the loan fees and all of that. So in your report, you can copy and paste the graph, put all the fees, explain each one, put your monthly payment. You can copy and paste the output box so I can see all the numbers. And you also send me the Excel so I can change numbers. And what I'll be doing when grading the Excel is I'll change the value of the house, and the new payment has to be the one that it's supposed to be. If I change a fee, it has to work, so everything has to be linked and connected. So you're not going to start maybe today because you're studying for the exam on Wednesday. But you have about a week and a few days to complete this. So, and remember, it's individual. If you forget it's individual and you put both names, split the grade in two. I don't know, something like that. No, I won't grade it. So, okay. Any questions? Okay. So if you've been coming to class, you should have already the basic, the structure, and if not, you can go and watch the video so you can put something together and then add on top of that. Okay? Try to make it. I do grade this. It's not a huge component, but if it's all over the place and I have to click here and then go here and there, that it's going to take a few points off. So make it so that you have an input box, an output box, and the table, and everything is clear. I can see all of that. All right. Okay. So let's continue reviewing for this. Did I open? Okay. Last class we reviewed what? We downloaded data, and we did again the histogram. We did max, minimum, count if, all of those commands, average if, median, mode. We did some pivot tables as well last class. Let's do some OLS. And even though I don't have a new file, we can use the same one. But try doing this without looking at the video or notes. It would be, which one is it? This file right here. Open the if-then regression file. And if you recall, I gave you a bunch of grades from a class, and you had to use if-then commands to count who gets an A, who gets a B, who gets a C. So know how to use if-then commands. But more importantly here, regression. What we had here was you had historical data, 19 months, and this is the total cost for the company, and this is how many units of A, B, and C were made in each one of those months. Okay? So what I want you guys to do is make an equation for me so that we can forecast what would be the cost to the company if you make the following number of units, 250, 300, and 450. Okay? So you expect that demand from A, B, and C units. You have that historical data. So I'm asking you, give me an equation that we can use to forecast what the total cost will be. You have to use regression commands. In your data menu, maybe you have to add it again. More than likely you have to. So let me give you a couple minutes 3-4 minutes to try to do this. Part of learning Excel or anything, you can't memorize every single step or every single command. But if you know how to use some commands in Excel like really well, then you want to use a new one, and it's the same template, same format. You select data in the same way. So if I tell you go to data and then data analysis, well, I don't have data analysis. You should be able to, add it on your own. And then you're going to be using the regression command. So give it a try. So we got data analysis, regression, click OK. Y range will be, that's your dependent variable, which is cost in this case. And then Y range, X range is your independent variables. And you can select the title or the labels. Make sure you click here, labels. You want the output range in the same worksheet. It helps. So you click here. I'm going to put it right here. And then there's no need for any of those graphs, so click OK. So that's the output right there. And then this is your Y range, and these three are your X range. So this is a dependent variable, and these three are the independent variables. So what is the equation? It will be equal to the coefficient, which is the number right here, plus the coefficient for A times number of units of A plus the coefficient for B times B units plus the C coefficient times number of C units. So that will be the forecast, and we can convert that into dollars and cents. So if you're the manager and that's your production estimation, you will estimate about almost $40,000 for cost. Will be total. How much of that $39,000 is fixed cost? It will be equal to the intercept, because that's a y-intercept, meaning when all the x's are equal to 0, you still have a cost. So that will be the number, and we can do that. So how much will be variable cost? It will be total cost minus fixed. It will be about $4,000 will be variable cost. So if you're the manager, what is your main concern in running the plant? The fixed cost. That is the biggest expense they have here. Okay? That will be a concern for the manager. Even if you don't make anything, you still have a really high cost to cover, so you need to keep the plant running. And then once you have that equation, once you have the numbers, you can change those to different numbers. Your fixed cost is still the same. Total cost went up, so I put more units, so then your variable cost also goes up. Okay. Now, if we look at the output here, that R squared, 0.64. What does that number mean? 0.64 means what? Yeah, but variation in what? .4, 0.5 maybe % of the total cost is explained by the number of A, B, and C units produced. That equation is not perfect. When you do OLS, when you do regression, the equation doesn't explain 100% of anything, especially in business, economics, and finance. But if you want to know, so what is causing that total cost, 64% can be explained by those three variables. Okay? So there are other variables that account for the remaining of the total cost. We just don't have them here. If you want to find out, then you have to do more research in your company. Okay? Let me show. All right. So, all of these you have to know for the exam. What else can I ask you here? Let's go to the p-value. This one's right here. Let me highlight them. What do those p-values mean? We have one that is basically equal to 0, because that number means what? It's point followed by 12 zeros. So it's basically equal to 0. It's just that Excel is very precise and it can give you the whole number. And then we have a 0.23, 0.02, and 0.01. So how do those p-values help you to evaluate your model? What is the p-value telling you here? Meaning, so 23%, if you run this number of times, 23% of the times, the coefficient will be equal to 0, meaning it doesn't really help you with your analysis because it's equal to 0. It doesn't really explain. Because if I make the coefficient equal to 0, it's not going to have any effect in my equation. Now, what is the p-value we use in business? Anything above, what did I tell you? 10%, we exclude those variables from the analysis. Okay? So what do you have to do in this case if you want to improve your model? Okay? And how do you do that? You run the regression again, but you don't include the A. Okay? So if you do that, what's going to happen? I'm going to go to data analysis, regression. The Y range will be the same, and the X range, now it's going to be only B and C. I have to pick a new place. And you can see that the p-values are even better now. Does it always help to do something like this? I mean, sometimes, but again, this is regression, and there's always error in the regression. But look what happened to the R-square. Now it's only 60%, so it explains less than before. So having 8 will have some value. Even though 23% of the time it might be equal to 0, it does explain some of the total cost. So you will definitely keep it. How am I going to ask you this in the exam? I'll ask you guys to run the full model, give me the equation, I'll give you some numbers so you can give me an estimate of total cost or whatever happens to be the scenario. And then if I ask you how will you improve this model based on p-value, if you see any of the variables with a p-value greater than 10, rerun the model excluding any variable with a p-value greater than 10. I will not get into tell me which one is better because that's very subjective. It depends on the situation. You will have to know more about what's going on here. Okay? So make sure you can do things like this. Okay? All right. Questions about regression? Huh? Okay, so let me see what else we have here. OLS. Okay. For the loan amortization, make sure you have your the one we work in class so you can give me the total payment, minimum scheduled payment. Or if I ask you in payment 300, how much is in principal, how much is in interest, you can go to your amortization table, find the numbers. If I tell you how much interest between payment 3 and 40, then you use which one? Cumulative interest payment. If I ask you how much principal is paid between payment 20 and 40, then you use cumulative principal. And then lastly, as far as review goes, time value of money. So expect to find future values, present values. We did those calculators, if you recall, so I'll be asking you for that. There will be annuities, there will be lump sums, there will be all kinds of stuff. Let's do some examples. Let's see. Let me open the one we worked in class. Bless you. Let me give you a scenario. If you have your calculators open, you can do this one. Let's see. So the way I do this one with my principals and students is you go on spring break and you run out of money, so you apply another $1,000 to your credit card. So you come back, you start making monthly payments, you send the minimum monthly payment, which is 20, 40 for some credit cards. Your APR is 24%. How long until you finish paying off the $1,000? How long is it going to take you? And credit cards you always pay at the end of the month, so it will be ordinary annuity. Let you guys work on that one. And you may have to modify the calculator that we did in class. It's not working. Why not? Does anybody have the answer? It's giving me an error. I don't know why. Future value, $1,000. Bless you. Payment, present value. Let's make the APR. You're getting an error? You keep getting that? Does anybody? I just figured out why, but does anybody know why? Reason if you what? Yeah. Well, it will be 20 per month, okay? And that's what we put here at PY. So you have to make that 12. Okay? You get a number, minus 30 something. Yep, you know, it can be minus 35. Okay, when you do time value of money, you have to let the calculator know when it's a cash inflow and a cash outflow. So this is between you and the credit card company. So you get $1,000, so that will be a positive cash flow. And then you're paying back 20 per month, so it will be minus 20. So if you put here 1,000 and then here minus 20, it's giving you that number. But minus 35 means, will that be 35 years or 35 weeks or 35 days or 35 what? Months, because you have everything in months. and you're not going to finish in 35 months. It's too soon. And what happens here is, with APR 24%, if you make payments of 20, you'll never finish paying off that loan. So let's make the APR 18%. So I've removed some of the negatives in the equation. Sometimes you can do the following. Let's say you're trying to use Excel as a calculator. You can do insert formulas, insert function. This one, which one? MPER, number of periods. I can zoom in, but rate will be equal to what? If it's 18% APR, you will do 0.18. And then to make it monthly, divided by 12. And then the payment will be minus 20, because you're making payments. Present value, you receive $1,000. And then future value, you can omit that one, or you can make it 0, because you want to finish paying off the loan. So it gives you an answer of what? 93. So that would be 93 what? 93 months. That's how long it will take you to finish paying off $1,000. In years, how much is that? 7.8 years. So it'll take you a very long time. Okay, $1,000. And how much are you going to pay in total? When you give the last payment, it will be equal to what? 90. Let's use that number. 93 months times each payment is how much? 20. So you'll pay $1,862. How much was the principal only? $1,000. So how much of that is interest? So you almost pay twice as much if you send the minimum payment. And that's why credit cards, they love you when you send the minimum payment. They make a lot of money when you send minimum payments. So, I'll be asking you, things like that where you have to do time value of money. What else? Let me think of another one here. If you will need $12,000 in 5 years, how much do you have to save on a monthly basis if you can earn 3% on your investments? Use this one, right? So N will be the 5 years, 3% to this monthly. Nothing here. And for this one, you can always double check with a financial calculator. You can use a calculator in the exam as well. It's up to you. You have that number? 186? So if you do that, you'll have $12,000 in 5 years. Yes? No, the exam, it will be a combination of multiple choice and Excel. So this ones, it will be multiple choice. So you give me the number, 186, so you mark that in your Scantron. Others, like when you download the stock price data, you have to do the histogram. You will save the file and send it to me before you leave the classroom. And then I'll open the file and go and check that you have all the elements. So if I ask for how many are positive, how many negative, the histogram, I'll give you partial credit for if you didn't complete the whole thing. And then this one's, be right or wrong. You either get the number or you don't get the number. No, because you can have all of this. So if I ask you for something like this, you can open your file, work out the numbers, and then you give me the right answer. The one where you have to download stock price data from scratch. The pivot table, I'll give you the pivot table, and then you start from there. Financial ratios, I'll give you the data, and then you make the pivot table, and then so it's not completely from scratch. Okay. Now, lastly, in the exam, you don't have to do spin buttons or option buttons. Those are for the models that you turn in. That's cosmetic. Doesn't help you with getting to the right answer. So you don't have to know how to do that. But anything else, making a graph, if I ask you to make the graph, use a scatter plot, so you can send all that to me. When you study we did last class, so I'm not going to repeat it, but when you download the stock price data, described to me is the distribution normal. So you make the histogram, and then you tell me kurtosis, skewness, based on those numbers, whether it's normal or not, whether it looks normal or not. So you'll have to type things like that. Now, something I saw when I was grading your models, I'll do it here, kurtosis and skewness. Kurtosis for a normal distribution is 3, right? And skewness for a normal distribution is 0. Now, when you calculate these numbers in Excel, some of you are getting things like this. For a skewness, 0.7. And then you talk about that's 70%. So it's very, very skewed because 70% sounds like a big number, but you don't convert those numbers to percent. You just use the 0.7. So it's a slightly skewed. It's not. If kurtosis is 2.5, it's not equal to 250%. It's just 2.5. So it's a slightly less than 3. So don't convert those two to percent. The other numbers like max and minimum, if you're doing returns, you can do 30% or 40%. Those you can convert to a percent. So be ready to explain that. Something else that you didn't quite explain in your reports is this mean reversion, okay? Which means when you plot your stock returns, it looks like a jagged line like this. So you have the mean. So anytime the stock return deviates from the mean, it has a tendency to come back. It's going to overshoot in the other way. It's going to come back, and that's why it shows that behavior. That's why if you ask somebody, give me your best estimate for the stock price, forecast, it will be the average. Because over a long, long period, you can see the stock price return always returning to that mean. Okay? And you're going to be accurate a lot of time just by using the mean. Okay? Have you taken investments, advanced investments, some of you? Have they given you the dog and the drunken analogy when they talk about stock returns? No, they didn't give you that one. So you have a drunk person walking a dog. So they're connected by the leash, okay? So they're going to get to point to the destination, but they're going to go like this. So the leash is that reversion to the mean that the drunken person is walking this way and the dog is going the other way, so they're going to pull each other, and then they're going to go apart again, and then pull each other. So they're going to make it, but they're going to go like this. But they all have a tendency to come back to the mean. So that's what that behavior means. It's one of the best analogies you can find, especially if you have done that. Anything else? No? If not, I'll let you guys off early today so you can use the time to study. Regular scantron, yes. I'll stay here. We still have time in class, but I'll stay here so that if you want me to go to your computer and ask me something specific, I can help you.